Hi, you're listening to Ice World Podcast. I'm your host, Rob Taylor. Seals from space. How do you go about spotting something that's 2 meters long from space from an orbiting satellite? I'm here with Prem Gill, and Prem's going to tell us about some of the work he's doing on this very subject. Prem, welcome to the show.
Hi, it's a pleasure to be here at Rotherham Research Station.
So Prem, tell us a little bit how you got involved in this project. How did it all start off for you?
Okay, so a few years ago I was looking at potential PhD options, and I have a background in marine geography, so I was already interested in the sort of marine side of things, and I had done a dissertation where I was using GIS mapping and satellite data to create a open source model to basically map where you have areas of biodiversity in the ocean. So I wanted to sort of carry on utilising my skill set, which was a bit of programming, a bit of satellite data analysis, GIS, and with application towards marine conservation. And then I saw a PhD advertised at the University of Cambridge with the British Antarctic Survey, in which it was essentially using satellites to study seals from space, and it sort of looked like it was the dream PhD tailored to my CV. So I very excitedly applied, and I was very lucky to be offered the scholarship to do that PhD. And 2 years later, I'm in Rotherham looking at Antarctic seals up close and personal.
So what does that involve at the moment? So you're here for how long?
I'm here just for 2 weeks. I'm pretty much at the end of my 2 weeks. I fly out on Monday and today is Saturday evening. So yeah, I'm pretty much at the end of my little fieldwork project.
Great. And what have you been doing for the last 2 weeks then?
So for the last 2 weeks, I have been walking around with a very, very big backpack, which has got a 5-meter pole. And on the end of that 5-meter pole are a bunch of sensors. One is to measure all the light that is reflected of various objects. In this case, it's measuring the light that's reflected off different Antarctic seals. And the other is just a thermal camera to take infrared imagery. And I've been walking around with my sort of supervisors, field guides and volunteers to go around and find different seals and just take thermal images and measure the light that's reflected off them.
So what's to stop us using regular satellite imagery that the human eye can interpret to count seals and get an idea for the population? What is it about thermal imagery that makes that better?
So the base of my PhD is using this very high resolution satellite imagery. And when we say very high resolution, what we mean is a resolution in which each pixel is less than a meter. So in my case, I'm using satellite images with a 30 centimeter resolution per pixel. And just to give you a bit of context, that means if you were to leave a laptop out in Antarctica, we would be able to see it in our satellite images. That also means you can see seals, you can see baby seals, and you can even see blood on the sea ice from where a seal has given birth. However, if you have rocks which are a similar shape to the seals and found in similar locations along the coast, it can be really, really tricky to tell the difference between seals and rocks, because essentially you're just looking at two black blobs on a white background. And this is where this fieldwork project comes into it, because to the human eye, it's really difficult to tell the difference, as I've mentioned. But if you're using a field spectrometer, which is what I've been carrying around for my fieldwork, and you measure the light that's reflected off seals, perhaps in ranges of light, in wavelengths of light which are invisible to the human eye, such as UV and infrared, there may be certain characteristic signatures which are unique to different seal species, and also help us differentiate seals from landscape features such as rocks and melt pools and shadows. And if that's the case, then you sort of don't have to rely on what these two black blobs look like just to the human eye, but you can begin to analyse what you think may be a rock or a seal in different wavelengths, which are invisible to the human eye, and go, the sort of reflectance of this object is very characteristic of a Weddell seal or a crab-eater seal, for example. So it's just a way of validating whether something's a seal or a rock, which is extremely difficult to do with just human eyes alone. It's essentially expanding our range of what we can see to help us identify different species and what's seal and what is not seal.
So the work that you're doing at the moment, and I want to come back to this is going to go into a bigger project by yourself, which is looking at, from space, how we can count how many seals there are in Antarctica.
So a big issue we have when it comes to the study of Antarctic seals is, despite the fact that they have the largest population sizes of any of the groups of seals, a big issue is simply due to the fact that they live within the sea ice zone. It's extremely difficult, expensive and dangerous to study these species. That means we have a really poor understanding of the population size as well as their habitat preference, and it's really critical that we understand, we get a baseline of the population to see if it's going up or down, as well as an understanding of what exact habitat preferences they may have, because in the coming decades, sea ice, which is the habitat they live, breed, and rest upon, and they use for foraging, that's going to be declining critically in the coming decades. So we really need to get an understanding of how they utilise that habitat before it starts to disappear, to get a better idea of how they will fare in a changing world. And if you look at species such as walrus in the North Pole, what you see there is they have shown a preference for certain types of sea ice. For example, they like very angular sea ice rather than rounded sea ice, and that has a big implication, because it's not just a case of is there sea ice or is there not sea ice. When you're looking at the threat of climate change to a walrus, for example, you're starting to go, well, this has a very niche preference, and even if you have a certain type of sea ice, if it's not the one it likes, even that will impact its ability to adapt in a changing world. So it's just trying to figure out how these species can adapt to a changing world and what's their current status.
Okay, so the field work you've been doing for the last little while, that's going to let us have far more idea when we're looking at these satellite heat images or kind of UV images, what species exactly we're looking at. So will humans be counting these, or is this being done by machine learning, or how are you going to get an accurate number from, obviously, huge file sizes?
Yeah, so these data sets that we're looking at, extremely big, and as you've sort of hinted, going through it manually, you can spend hours looking at images of sea ice and not find any seals, and it's one of the most soul-destroying processes known to man to go through that. So we're very interested in automating this, and there's been some work by Heather Lynch's group in automating this using machine learning, and there's been some promising results there. But for the most part, for me and my research, because I don't come from a computer science background, it's really the main focus is perhaps using the manual counts we have of the seals, so seals we've already studied manually, but doing it over small study sites in lots of different habitats to try and get an idea of what the habitat preferences are of different seal species in small study sites, perhaps areas where we're seeing large changes in climate change, for example, along the Antarctic Peninsula where we're currently based, or Cygnus Island where you're having these big reductions in sea ice and you're having this southward increase in the range of non-sea ice sort of specialist species. So that's the fur seals and the elephant seals, and sort of getting an understanding of what's the interplay between the competition between these species as well as the change in habitat, how that's going to impact your Antarctic seal species, and using satellite imagery to sort of gauge what's going on there, but then also looking at more stable sites that you have, perhaps say on the East Antarctic, where the same sort of signal we've seen from climate change along the peninsula and along Cygnus Island and the other subantarctic islands isn't very evident there yet, and just getting an idea of how these species can, how they differ over sort of small study sites which are representative of differing habitat regimes, essentially.
So the fieldwork you've been doing for the last 2 weeks, you've been getting 5 meters away from elephant seals, Weddell seals, crab eaters, and fur seals. Anything else? Have I missed any?
That's it so far. So really all the species I want to get are, well, all of the Antarctic seals. So that's elephant seals, that's fur seals, Weddells, crab eaters, Ross and leopard. Unfortunately, Ross, I haven't seen any, and according to one of the boating officers, he thinks he may have spotted one last week, and apparently there is one that's known to be in the region, but it's seen very infrequently. And the other species which I haven't been able to measure is the leopard seal. And it was very frustrating actually, because on my second day here, looking outside of my office window at the Bonner lab, I could see a leopard seal on an ice floe with a crab eater, two of the seals I wanted to study. But unfortunately I was stuck in induction training, so I couldn't just hop on a boat and go out and survey them. So I've got all of the species I'm after except for Ross and leopard. But Ross I didn't think I would get anyway, and the leopard, well, I thought that would be very hit and miss. So I'm quite happy with what I've managed to get, especially the fur seals, because I thought they would be a little bit too feisty for me to be able to approach them. But with a lot of tiptoeing and sneaking, we have managed to get them. And very fortunately you were out with me this morning while we were sneaking around looking for fur seals, and we managed to get some what seems to be quite good data on the fur seals while we had a nice big bright sunny day.
For our listeners, this is pretty much exactly what Prem and I were doing early this afternoon. We had the 5-meter pole, we had a laptop and a sheet of white material for calibration purposes, and we did sneak around some rocky beaches, trying not to make too much sound, on fur seals as they were napping in the sun. We managed to get some quite good data off of those, so it'll be cool to see how useful that is.
Yeah, well, I have to say, a very annoying thing about fur seals is they have very heightened senses, very feisty, a bit nervy, and they prefer to be in rocky areas rather than sea ice areas. So just walking over there with a light foot and not making any noise is really, really difficult. But I'm quite impressed that we managed to get a few, because in the first week we sort of accepted that it wouldn't be possible. But by the time we had really gotten grips to what we were doing and got the methodology down, we were able to sort of incorporate our sneaking and find one or two sleeping little fur seals. So yeah, it's worked out quite well.
So you're heading home on Monday.
Mm-hmm.
You're going to take this data that you've managed to gather while you're down here, and how long do you think till you're able to show some results from this?
Yeah, it's a good question. I'm not sure, because I've never analysed spectral data before. It'll be my first time doing it. A colleague of mine is doing a very similar study. So one of my supervisor students, Hannah, she studies whales from space, and she's looking at the spectral reflectance of whales, and she collected some basically samples, frozen samples of whale skin, which were extracted from, I think, just washed up whales. And she took, I think it took roughly a year to go from actually doing the study to having the data written up in a paper. And I think the paper was released just today on that, I believe. So perhaps it could be a year. I'm not totally sure, but to get a rough idea of if there is a difference, it'll be quite quick. And I guess one result is no one's ever collected the spectral reflectance of Antarctic seals. So in essence, we have a result already in that we've done something that no one has done yet.
That's potentially a useful tool for various other applications as well. I'm sure people could find lots of uses for that.
Yeah, I mean, the hope is not only will this allow you to really get a better idea of whether or not the seals in your satellite imagery are truly seals or not, and perhaps a different species, but perhaps this is something we can add to drone setups. And at the British Antarctic Survey, we have something called a Prion 3 UAV, which is a fixed wing drone. Essentially a small aeroplane that has a flight time of 13 hours, I believe. And what I really would like to do is come back next year and do a similar study, but from an airborne application point of view. So putting these sensors into a drone or a twin otter and trying to scale that up to that intermediate interface between on the ground and satellite, which is the aerial realm, and looking to see if we can begin to do automated seal surveys across the peninsula using our very, very fancy drone.
That's exciting. I mean, I know that the penguin aero survey that happened this season was a big success.
Mm-hmm.
So if we can do the same thing for seals, that'd be quite exciting.
Yep. It'll be sort of working off the sort of resources in the background that's been set up by the very successful penguin surveys and to sort of keep the ball rolling and incorporate seals into that programme.
That would be really good. Prem, thank you very much for coming on the show.
Okay, no, thank you. It's been a great pleasure.
And hopefully, if you come down in a year or so, or if I run into you in Cambridge, we can do a follow-up episode and find out how the project's going.
That would be awesome.
You've been listening to Ice World, a podcast on behalf of the British Antarctic Survey. If you want to learn more about the survey's work in Antarctica and beyond, please visit our website at www.bas.ac.uk. Thank you for listening.